What's up, guys? The video for you right now is about quadratic word problems factored form. Anything that has to do with solving an equation where it's given to you with a real-world scenario. The first problem that I'm solving says the power generated by an electrical circuit as a function of its current is modeled by the formula P of C equals negative 15C times C minus 8. The zero product property is probably a video or some skill that you should work on before you've really dived into these. Although to explain it simply, in the product property, you have a factor like negative 15c and it equals 0. And you have another factor like c minus 8 and it also equals 0. Because when you multiply two things, either one thing is 0 or the other. And check out the work there. I'm solving for c in both of those cases. I get an answer of 0 and 8. C equals 0 or c equals 8. And those are like x-intercepts. I mean, they're not technically x, but they're like on the horizontal line. That's where the graph crosses the y-axis. Continuing to solve it, we are trying to figure out where this current will produce its maximum power. Well, because of the shape of a parabola, which is symmetric, the place where the graph crosses the x-axis on either side are exactly halfway between. So we use the idea of average, add up the intercepts and divide by 2, and that answer is exactly in the middle. Okay, I see here another problem, a company's annual profit in millions of dollars as a function of an app's price is modeled by an equation. P must represent profit. So capital P of x equals negative 2 times the quantity x minus 3 multiplied by the quantity x minus 11. Each of those are factors. Negative 2 is a factor, but it doesn't really do anything in that it doesn't equal 0. The negative means the parabola opens down. X minus 3 is a factor, so set it equal to 0 with the zero product property. Set it equal to 0 and solve for x. 3. X minus 11 is a factor. Set it equal to 0 and solve for x. 11. So when x is 3, you put 3 back in. That's x 3. $3 per app. You're buying an app at $3 an app. So putting 3 into the equation, you get 0, as in you're going to need to make everybody pay at least $3 in order to make the company like its money back. Or $11. You make the app worth $11 and people buy it and you don't sell enough of them, so you still don't really make any money. But that's the result where you're still going to have some, in between $3 and $11 per app is going to be where you have any form of money, any form of profit. So anything outside of 3 and 11, like 2 or 1 or none, or 12 or 13 or 14, etc., the company will actually lose money. So these problems are about interpreting what's going to happen. So it'd be helpful even to graph it. I don't show you graphing it here. Desmos is a great place to graph. Shout out Desmos. Whoop, whoop. In this problem, the company's annual profit, same thing. But now we want to know what would be the company's profit if the app price is $0. There are key features of a quadratic function you need to understand. A quadratic function might have x-intercepts. Like the last question, that represented where the profit would be 0. In this case, we're asking you about what happens when you sell it, what was it? For no dollars. That's a y-intercept. What does a y-intercept mean? And it's actually like how much money the company would lose. And then halfway between the x-intercepts is a location of the either maximum or minimum value of this. Either the most amount of money you can earn or the least amount of money you will lose as you interpret your scenario. So in this case, talking about maximum power possible, we're looking for what's exactly halfway between the intercepts. And I'll let you finish solving that question, but there you have it. Thanks for watching this video. You might want to give the other quadratic equation or quadratic solving questions some of your attention. Just kind of figure out what's going on. Thanks for watching the video. Thanks for doing some math with me. See you in the next video. Bye.